Good evening, sir. My name is A. Pujyalekana. Now I am going to tell about the signals approximation and mean square error. Introductions of the signal. First, the definition of the signal. The signals are the functions that convey information, typically varying with time or space, and can be analog or discrete in nature. Second one is the types of signals. Signals can be categorized into the continuous and discrete signals, both of which can represent various physical phenomena such as sound, light, and data. The third one is importance of a communication signal. Understanding signal is crucial in communication system where they are transmitted, processed, and analyzed for effective information exchange. And the next one is the orthogonal signal. The definition and properties of the orthogonal signals are: orthogonal signals are set of signals that are mutually perpendicular in a vector space, yielding in an inner product of zero. The applications of the orthogonal signal, widely used in the communication system, such as orthogonal frequency division multiplexing. It is also called as OFDM. The benefits for the signal processing orthogonal signals are: it reduces an interference and improves clarity, enhancing signal recovery in noisy environment. The next one is mean square error. The definition of the mean square error is: mean square error is a measure used to assess the quality of an estimator or the accuracy of an approximation, defined as the average of the square of the errors between the estimated and actual values. Second one is calculation method. The calculation method of the MSE, it means mean square error, is calculated by taking the average of the square of all errors, providing a clear quantifiable metric for evaluating signal approximation. The formula is MSE is equals to 1 by n summation of true signal minus estimated signal whole square. And the third one is significance in signal processing. A lower MSE, it means mean square error, indicates a more accurate approximation, making it a crucial criterion in selecting the best signal representation. The examples of the mean square error. To understand the mean square error in the context of signals and system, consider the following examples. The first one is true signal. True signal means assume we have a true signal represented mathematically as s of t is equals to sine of t. And the second one is estimated signal. Suppose we approximate the signal using a simplistic model as E of t is equals to 0.a star sine of t plus 0.1, which adds some error. The third one is calculation. We calculate MSE, it means mean square error, over a defined interval by squaring the differences between the true and estimated signals, averaging them across the time interval. The formula is used. The formula is MSE. It means mean square error equals to 1 by n summation of S of t minus E of t. S of t is denoted as true value, E of t is denoted as estimated value. These examples illustrate how different approximations, the quality of signal representation, setting the stage for the next discussion on the orthogonal signal and their reduction of MSE. It means mean square error. Orthogonal signal and MSE. The definition of the orthogonal signal. Signals are the orthogonal if their inner product is 0, and the application of the orthogonal signal is used in the communication system to enhance signal clarity. Impact of MSE. Orthogonal signals minimize MSE by avoiding interference. Mathematical representation expressed as E of x1 star x2 is equals to 0 for the orthogonal signal x1 and x2. Signal approximation techniques. First one is projection method. One popular technique involves projecting the signal onto the space spanned by orthogonal basis functions, which helps in the generating efficient approximation. The second one is linear combination. Signals can be approximated using linear combinations of orthogonal signals, lever leveraging their properties to assure minimal overlap and error. Velvet transforms. Advanced methods such as wavelet transforms utilize orthogonal wavelet bases for multi-resolution analysis, further decreasing approximation errors. The case study of the signal reconstruction. Real world application. A case study on signal reconstruction demonstrates how applying orthogonal signals significantly improves the reconstruction quality while maintaining low MSE. Results overview. The results showed as substantial decrease in MSE when using orthogonal approximations comparing to traditional methods, highlighting their effectiveness. Implications for further research. This case further opens avenues for research into other applications and adaptations of orthogonal approximation across various types of signal reconstructions. Challenges in signal approximation. Uh, Computational complexes. High High computational requirements can be a barrier requiring sophisticated algorithms for practical implementation. Noise. The second one is noise sensitivity. Signal approximation can be sensitive to noise, leading to increased MSC if not managed appropriately. The third one is selection of the basic functions. Choosing the most suitable orthogonal basis functions is critical and impact the quality of the signal approximation. Further directions in the signal processing. First one is improved algorithms. There on there there's an ongoing need for developing more efficient algorithms that can be handle increasingly complex signals while maintaining low MSE, means mean square error. Integration with machine learning. In incorporating machine learning techniques for dynamic selections of the orthogonal basis in real time application promises enhanced signal processing outcomes. Extensions to the non orthogonal signals. Future research can be explored to the adaptation of the signals to a the next one, the conclusion on orthogonal signals and the MSE. The first one is summary of a key points. The presentation demonstrates the critical role orthogonal signals play in the approximation process and the importance of MSc as a measure of efficiency. The second one is impact on signal processing. The integration of orthogonal signals and MSc has far reaching implications for improving the quality of various signals processing the applications. Call for uh, continued research. Ongoing advancement in the field will require continuous research and exploration of innovative approaches to signal approximation. Signal processing references. The first one is important books on the signal processing, a selection of a comprehensive texts that delve deeply into both the fundamental theories and the practical applications of the signal processing. The second one, cutting edge research papers in the signal processing, an overview of current methodologies and the latest innovations that are shaping the future landscape of the signal processing. Valuable online resources for learning and network, a curated list of websites and forums that provide continuous learning opportunities, resources, and community support in the. Thank you, sir.